everybody. In this video, we will be solving equations. Now, you have already solved quadratic equations, so polynomial equations aren't going to be much harder. The first step is still the same. We want to get the equation equal to 0. So I'm going to first subtract 28x from each side. So now the equation is equal to 0. Next, if I can factor the equation, that's what I'm going to do. So notice, whoops, miswrote that. So notice that these terms all have a common factor, right? And actually the greatest common factor would be 2x. I can factor out a 2x from each of these terms. That would leave me with x squared minus 5x minus 14. Now I'm not done, because now I still have this quadratic expression inside. I'm going to try to factor just this. So I still have my 2x. And now let's see. If I factor this, I can start each of those off with x and x. To multiply to negative 14, I could use 7 and 2. Which one of them should I make negative? Let's see. I want them to add up to negative 5, so I should make the negative 7 and then that a plus 2. Right? So now they multiply to negative 14 and they add up to negative 5. Perfect. So notice the first step, I'm going to go back here for a second. We set this equal to 0. Set the equation equal to 0. Then we factored completely. Now it's just like a quadratic equation. I'm going to set each factor, there are 3 of them here, set each factor equal to 0 and solve. So 2x might be equal to 0. So if I divide both sides by 2, that means x equals 0. That's our first solution. Maybe x minus 7 is equal to 0. Well, if that's the case, let's solve for x. X could be 7. And then for the last factor, x plus 2 equals to 0. Solve for x and you get x equals negative 2. So we have 3 solutions. Notice that our highest exponent is 3. That means that we should have 3 solutions. And we found them all. Let's try another one. Here's another example. Now notice the third term right here, I would call that the constant term, doesn't have any x's like these do. So I can't factor out an x. So I'm actually going to teach you a trick about this one. Notice that this is an x to the 4th. We're missing an x cubed term. Then we have an x squared. Then we miss just the x term. And then we have a constant. Whenever that happens, I always try and think of factoring it like I would a quadratic. So think about what would you put here and here to multiply to x to the 4th. Well, normally we're multiplying to x squared, so I would put an x and x here, right? That gets me x squared. But if we just change them to x squareds, then we'd get the x to the 4th. Excellent. Now let's try to multiply 2 numbers here and here to get negative 4. Well, I can think of 2 options. 4 and 1, one of them being negative, and 2 and 2, one of them being negative. I think that it's going to be 4 and 1 because we have this 3 right here. So notice that if I make the 4 positive and the 1 negative, that the 4 and negative 1 multiply to negative 4 and add up to 3. Ooh, look at this. If you wanted to multiply it out and check, you'd see that the x squared is multiplied to x to the 4th. The x squared times negative 1 is negative x squared. 4 times x squared is 4x squared. That makes a total of 3x squared. And then our 4 and negative 1 multiply to negative 4. Perfect. Now look at just this quadratic and see if you know how to factor that. What two numbers multiply to 4? Okay, 4 and 1 or 2 and 2. But notice there's no linear term here. So that's really like saying that there's a 0x term. So the two numbers that multiply to 4 also have to add up to 0. Well, that's not going to work. So I guess that one is as factored as completely as possible. But then we get to the x squared minus 1, which could be factored further. Two numbers that multiply to negative 1 and add up to 0 would be, let's see, let me set up my x's here. If I do negative 1 and positive 1, they multiply to negative 1 and they add up to 0. So that one's factored as completely as possible. I'm going to go back to the beginning here where I said this should have as many answers as the highest exponent. So this should have 4 solutions. Well, I see 2 of them right here. Some of you like to jump right to the answer. Okay, x equals 1 and x equals negative 1. Great, that's 2 of them. That means that this must have 2 solutions. So if I say x squared plus 4 equals to 0, how do you solve for x? Well, how do you solve quadratics? By factoring. Okay, we tried to factor. We said no, that didn't work. By graphing. If you actually graphed it, you'd see why that's not an option. Or quadratic formula. So we could do quadratic formula. Or notice that this is kind of simple. I could just subtract the 4 from both sides. And then to undo the squaring, I would square root. So x would equal 2i. Because the square root of negative 4 is 2i. Don't forget, though, that when you square root, you get plus and minus versions of the answer. So that's actually 2 solutions in one. Oh, and we have the 2 from before. So that makes a total of 4 solutions. Excellent. Let's try one more quick one. Here's an example, and I've already factored it for you. Awesome. So look, if this equation is equal to 0, well, we already know one of the solutions is going to be negative 2. Try factoring this quadratic. What multiplies to 5? 5 and 1. That's the only thing I can think of. You're not going to get that to add up to 3. So how are you going to solve this quadratic? Factoring's out. Graphing, we could try it. Or quadratic formula. I'm going with the quadratic formula. So A is 1, B is 3, and C is 5. Here I go. So x equals negative 3 plus or minus the square root of 3 squared minus 4 times 1 times 5 all over 2 times 1. Okay, I'm just going to simplify that. So negative 3 plus or minus, get out my calculator, just do the inside of the square root. Negative 11 over 2. Awesome. So now I'm just going to simplify that to show that I know that this is an imaginary answer. So the square root of negative 11 is really I root 11. So there they are, 2 imaginary answers for that one, and 1 real answer. That's a total of 3 answers. Okay. Time for you to try some. Good luck.